Hello everyone, I am Mrs. Vishali Chaudhary, lecturer Praveen Patil Polytechnic. Today we are going to learn practical number 2 for the basic science, basic chemistry. This is your manual. Today we are going to perform test for anions, that is a qualitative analysis. We are going to find out which anion is present in a given sample solution. What is the anions? These are the non-metals, the carbonate, oxides present in a solution we are going to find out. Experiment number 2, identification of anions. Anions are obtained by the ionization. When any salt solution dissolved in a water, it is divided or classified into the two types, anions and cations. In the first experiment, we determine the cations. Today's experiment, we are going to determine the anions present in a solution. Course outcome is to determine the catalysis process used in an industry. Practical learning outcome is identify anions in a given solution. Resources required. The requirement of apparatus, test tube holder, test tube stand, and chemicals and beaker. First we are going to take sample solution in a beaker. Then we will take required quantity in a test tubes and reagents are added, and we will check out whatever the changes take place in a solution. We are going to follow this table. What is that table? All these anions are divided into the three types. First anion, that is a carbonate group, that is identified by adding a small amount of the nitric acid. If carbon dioxide is present, then when we are adding dilute HNO3, they will show you bubbles. Did you observe the cold drink? Yes. When we are pouring the cold drink, like a thumbs up Sprite in a glass, what we will observe? There is a carbon dioxide bubbles coming through. That is called as a carbon CO3 2 minus may be present. When we are adding dilute HNO3 in an original solution, we will observe effervescence or the no effervescence. If effervescence are present, we will say CO3 2 minus is present. If no effervescence, CO3 2 minus is absent. We will perform the second test. Second test is OS plus AgNO3. We will add silver nitrate in a given solution. As we are adding silver nitrate, we will observe there is two observations. White PPT. If white PPT is there, chlorine, bromine, iodine may be present. If no PPT, chlorine, bromine, iodines are absent. If these three are present, we are going to separate out by using a chloroform and chlorine water. If chlorine, bromine, iodine are absent, we are going to perform the third test, OS plus barium nitrate. There are two types of result, white PPT or no PPT. White PPT inference is SO4 2 minus present. No PPT, NO3 2 minus is present. From looking at this diagram, you can understand how the test tube is carried out. Take small amount of OS, that is the sample solution, add HNO3. When we are adding HNO3, if there is a bubbles, we will say that carbonate is present. We are not going to perform test for sulfate and halides. If there is no bubbles, we perform the test for sulfates and halides. For the sulfate, we are going to add the reagent. If PPT, sulfate is present. If no PPT, sulfate is absent. Similarly, perform the test for halide. This is test for cation. Take a sea water. This is example. adding AgNO3, we will observe it is a milk color solution is present. That is called as white precipitate of silver chloride. So chlorine is present. If any sample anion is identified, we will perform the confirmatory test. Here we are performing confirmatory test for SO4 2-. OS plus lead acetate. If it shows the white PPT, we will confirmly say that SO4 2- is confirmed. OS plus barium chloride, we will say white PPT, SO4 2- is confirmed. We have to perform any two tests. See, this is the confirmatory test of SO4. We are taking sample solution here. We are adding barium chloride. When we are adding barium chloride, we will observe that the solution becomes completely white. The white color precipitate is formed. So we will say that SO4 2- is present. After this video, I am going to add actual how the practical will take place video. We are going to write observation in your manual. How we are going to write? First, whatever the test we perform, first we take a OS. OS matlab sample solution, test solution. Adding dilute HNO3, we will observe. What we will observe? There are two types of observation: effervescence or no effervescence. If no effervescence is observed, we will say that CO3 2- is absent. OS plus AgNO3. No PPT, chlorine, bromine are absent. Third test. As first two are absent, we are going to perform the third test. OS plus barium nitrate, white PPT, will confirm say that SO4 2- is present. As it may be a present, we will do a confirmatory test. OS plus lead acetate, white PPT, SO4 2- is confirmed. OS plus barium chloride, white PPT, SO4 2- is confirmed. Similarly, we can do an identification test for carbonate, chlorine, bromine and nitrate. We are going to write result in this format. Anion identified in the sample solution 1 is SO4 2-. That is obtained by dissolving FeSO4 salt in a water. Sample interpretation is sample solution 1 contains SO4 2- anion. These are the practical related questions. Identify acidic radical present in a given solution, which gives effervescence of CO2 gas with a nitric acid, which are the carbonate group. Explain the separation test for halides in a sample solution. Chlorine, bromine and iodines are called as halides. They are separated by adding a chloroform and chlorine water. And we will observe the color. If third question, identify anion in the solution X. When mixed with the barium nitrate, it gives a white PPT. What is that? This is the wrong answer. If SO4- is present, it will give you white PPT with the barium nitrate. Thank you so much. After this, I will show you how exactly will take place. We are going to perform experiment number 2, identification of anions. There are two solutions are there, solution A, solution B. Earlier experiment we performed identification of cation. Now we are going to do identification of anion. For solution A, we are going to perform first. This is the OS. We are going to take OS. Then after first identification test is addition of dilute HNO3. So when we are adding nitric acid, we will observe there is bubbles or not. What is the meaning of the bubbles? Effervescence is there or not. As there is no effervescence, we will say that carbonate is absent. Second test, OS plus
Second test is OS plus AgNO3. What is meaning of AgNO3? Silver nitrate. Where when we are adding, there is no white precipitate. So what is meaning of that? Halides, chloride, bromide, iodide is absent, as there is no PTT, no changes take place. We will perform for the third test, third group. It is the OS plus barium nitrate. Here we will observe the white color precipitate is present. So we will say that SO4 2 minus is present. As SO4 2 minus is may be present, we will do confirmatory test. That is the OS plus barium chloride. White color precipitate is observed. So we will say that SO4 2 minus is confirmedly present. Second confirmatory test is OS plus lead acetate. OS plus lead acetate. OS means original solution. We are going to add lead acetate. Would you observe when we are adding reagent, there is a white color precipitate formation take place. So we will confirm say that SO4 minus is confirmed. Now we are going to perform identification test for the solution B. Now first we have to take OS. Then after we are going to add first identification solution is dilute HNO3. In that we will observe that when we are adding it,